Today we're going to be doing our single replacement reaction lab. And what we have here are 5 different metals. So on the first column down, you'll see that we have lead. So they're kind of dark in color, very small, pellet-like. We also have zinc. So that'll be the second column, a bit more silvery. The ones we have are slightly larger pieces of pellets. And then we have our copper. So it has that very distinct kind of shiny orange color to it. We skip a column just for in case there's an overflow. And then on the secondary well plate that we have here, this column contains pieces of aluminum. So here's our aluminum. And then finally, at the very end, we have magnesium. So magnesium is at the very far end here. Our goal is to add a solution to each of these metals. So as I go across a row, I'm going to be adding a specific solution. On the very first row, all 5 metals will be, we're going to be adding drops of zinc nitrate. And then the middle row will have lead nitrate. And then finally, the very bottom will have copper nitrate added to it. So now what we're going to do is, I've already preset this by adding all the metals that we have. So again, as a recap, lead is the first one, zinc is the second column, copper is this column. We have skipped a step right here. And then this is aluminum, and then finally magnesium. I'm going to add our zinc nitrate first. And on your handout, you'll notice that there are 2 boxes. One for your observations, and you want to be as descriptive as possible. Keep in mind that we're looking for evidence of chemical reaction, as we have discussed in class. So that's kind of the goal for this lab, is to find evidence of a chemical reaction. If it looks like the metal is just getting wet without any of the evidence we're looking for, then we could say that there is no reaction occurring with regards to mixing those 2 components. All right, first one is our zinc nitrate. So I'm going to try to add this as quickly as possible. I'm gonna, for some of them, because they float, I'm gonna try to submerge them. And every time I use our toothpick here, I gotta make sure it's rinsed off and dried up so we don't cross-contaminate. All right, so what we'll do is we'll give it some time. So all the way across zinc nitrate, it might be hard for you to see from the video, but currently there's no big significant changes that is observable for that first column. So keep in mind, we're going to record it again after a certain amount of time. Right now I'm going to set up the second one. So here is lead nitrate solution being added to the middle row. Okay, so let me use a different toothpick for this. Immediately, I'm seeing certain things happening to some of the metals. For example, I could see that our zinc piece right over here, let me use my toothpick to point at it. This one is going through a certain change. As a color change, it's now very dark, and it almost looks like it's forming bubbles around it. The other one that I could see changes happening would be our magnesium. So it looks like the magnesium is also developing certain changes to it, like observable color change, potentially kind of a change in, it seems like it's also breaking down. Finally, a little bit in aluminum. It looks like there is a color change as well for aluminum. So we're gonna give it some time to keep going. This time around, we're gonna add the third solution. That would be copper nitrate. Unlike the other solution, copper nitrate has a bluish, light blue color to it. The other two are clear. All right, again, I'm gonna use a different toothpick. I do need to make sure our metals are submerged, so I'm gonna try to push. The aluminum seems to be constantly floating. Dry it up again. Same thing for our magnesium, submerge that. All right, so at this point, I'm gonna pause the video. I do wanna note, it is the initial set of observations that we have. I could see that the second metal that we have, zinc, is also showing signs of changes of chemical reaction. Another one that seems to be displaying that there's a change in color, there's some bubble formation, that would be aluminum, and definitely I can notice that in magnesium. So I'm going to pause the video, and we're going to have the second part of the video will be after 15 minutes.